Hi, this is Brian Fogarty, and this is a video for Chapter 10 of the book Quantitative Social Science Data with R, second edition. So what we're going to do in this video is look at chi-squared analysis in R real briefly here. So chi-squared analysis is a type of statistical significance test that we can use in a bivariate analysis. And so what it does is that it looks at our data, our relationship, the cell frequencies in that cross tabulation. So it looks at our data and compares it to what a hypothetical no relationship looks like. If it's different enough, which is, I know, super squishy, if it's different enough, then we could say whether or not we have a statistically significant difference. We could do this by hand, where we look at stuff like the observed frequencies compared to the expected and do all this calculation, which I used to make my students do, which is terrible. I feel terrible about it. But we can use R to do it. So it's way faster. It's good, though, to know how it works. That's fair enough. I put in a bunch of caveats in the chapter on this, but chi-squared doesn't tell us like what is the right relationship. It is inflated by sample size, so if you have a large N, you're more likely to find statistical significance. It doesn't tell us anything about the strength of the relationship. That comes in with measures of association, but at least starts us down the road of looking at statistical significance. A big part with all of bivariate analysis is that it's just looking at two variables in isolation. It's not taking into account other potential effects. So it's possible that the relationships that we observe here that we find to be statistically significant in a bivariate case are not ones we control for other variables, which we'll talk a lot more about in future videos in chapter 11, or starting in chapter 11 and then also in the chapter itself. Okay, so let's do a chi-squared analysis. So what we're going to do is just come up, this is from the previous video, we're just going to come up here, steal this code, which again is always a good idea, and then we are going to add here chisq.test. So this function is actually from the stats package, which is part of base R. And when we loaded in the janitor library, we actually got a message saying that this is overriding the stats package version, even though it's the same version because it's just pulled in. Okay, so let's highlight that. So again, what we're looking to see is whether or not there's a statistically significant difference here. Okay. All right, so we're looking at the p-value. All right, I should say, so we could also, if we were doing this by hand, going that route, we would calculate a chi-squared value, calculate degrees of freedom, and then look up this value here in a chi-square distribution table, a critical value table, and see whether or not it's equal to or greater than. But R just gives us the p-value, so we can just go with that. So we're looking to see, is the p-value less than or equal to 0.05? So it is. So what we can conclude is that there is a statistically significant difference, or probably a better way, is that there is a statistically significant relationship between respondents' vote choice in 2017 and their views on whether or not voter fraud is a problem in UK elections. If we wanted to be more specific here, what we could do is phrase it as that respondents' vote choice in 2017 election is a statistically significant predictor of their view on whether or not voter fraud is a problem in UK elections. The reason why we could do that is because we are treating this as the predictor and this as the outcome. This is completely like our choice. It's not Again, this isn't causal, it's just observational. Okay, so again, that's real quick here. We're just looking super quick at how to do a chi-square test in R. All right, so thanks for watching, and I'll see you next time.